to this video. In this video, we are going to be looking at a sample question from the topic friction. So we are going to be seeing how we will deal with questions in topic friction. Though there are a lot of questions and there are a lot of formats in which questions can come from the word topic friction, but out of those numerous questions, we are just going to be looking at one cases out of all the cases in which question can come out from friction. So now, let's look at the question on the board. The question says that a force of 10 Newton drag a mass of 10 kg on a horizontal table with an acceleration of 0.2 meter per second squared. If the acceleration due to gravity is 10 meter per second squared, the coefficient of friction between the moving mass and the table is dash. So in this question now, in one of my previous videos that I did, I made a detailed explanation about the topic friction, and I give you about 12 cases in which questions can come out in friction. Now, interpreting this question and understanding this question, you find out that this question is coming out from case 1 of friction of friction. So let's interpret it and see how does it come out from what case 1 of what friction. So now solution. Now they told us that a force of 10 Newton drags a mass of 10 kg on a horizontal table. So meaning that if this is an horizontal table, we have a mass, say 10 kg. Now this is the direction of the force dragging it. So we are having what? 10 Newton. Are we together? They told us that this table have an acceleration of what? Acceleration of 0.2 what? Meter per what? Per second square. Which means that this body is already what? Is already in motion. True or false? True. So now, if this body is in motion and this is the direction of the force applied, remember that frictional force try to oppose motion. So if the force applied is pointing towards this direction, the frictional force will be acting towards this direction in order to oppose the word, in order to oppose the motion. So this will be the direction of the frictional force, and the frictional force here is the kinetic word, is the kinetic frictional word, kinetic frictional force. Now, aside this, you know that in every whenever a body is resting on the plane, we have two types of force acting already. One is acting upward, which is the normal reaction, and the other is acting downward, which is the weight of the word, the weight of the body. So now, resolving or finding the net forces in acting on this body, we are going to be having summation Fy equals to what? R minus what? Minus W. Now it is R because it is pointing towards the positive y-axis. Remember, in the Cartesian plane, this is the positive, this is the positive, negative, negative. So this R is pointing towards the positive word y-axis, and W is pointing towards the negative y-axis. So that is the reason we are having R minus what? Minus W. So if we should continue from there, remember that summation Fy, which is summation of the forces in the vertical axis, will give us summation NAY. C equals to what? R minus what? W. Now A will be equals to what? 0. That is the acceleration in the vertical component will be equal to 0 because there was no movement vertically. Now we know that the body was moving, but was it moving vertically or horizontally? It was moving vertically. So it was moving horizontally, right? So for that reason, the acceleration vertically is equals to what? Is equals to 0. So now, if acceleration is equals to 0, therefore means that everything here is equals to 0. So we are having 0 equals to what? R minus what? Minus W. So weight is equals to what? The normal reaction, and equals to what? Mg. Because weight is equals to what? The product of mass and what? And gravity. Are we together? So that is the first thing we need to know about the word, the vertical component. Now going to the word horizontal component, we are going to be having summation Fs equals to, now which of the forces is pointing towards the positive x-axis? We have 10, which is the force applied, Fa. Now minus what? Fk, which is the word? Which is the word? The frictional force. So now summation Fs will give us what? Summation Ma word, Mas, which equals to Fa minus what? F word, Fk. Are we together? So now continue for there. Remember, they are asking us to calculate for what? The coefficient of friction between them. Right? Now, if we look at this place, summation MAS. Now in summation MAS, the acceleration is not equal to 0 because it was in motion. So it therefore means that we are going to be having MA equals to Fa minus what? F what? Fk. Are we together? So in this place now, we are going to go, there's no way, if you can look at this question now, there's no way we are seeing our mu, which is the coefficient of friction, right? But remember that frictional forces is equal to what? Mu R. So mu r, depending if the normal reaction is equals to the weight, we can also rewrite frictional force to be mu equals to what, mg. So with that, we substitute it into this place. We have na equals to fa minus mu. Since the frictional force is kinetic frictional force, we are going to have mu k m mg. So this is the formula we are going to be using to calculate for what? To calculate for our what? Our coefficient of what? Coefficient of friction. So now in this place now, you agree with me that we are having force applied, we are having the force applied, we are having the mass, we are having the acceleration, and we are asked to look for what? The coefficient of what? Friction. So let's just make use of this place. Permit me to clean the equation. So I've cleaned this part of the board. Now let's continue. So remember that the mass is what? Is 10. So we are going to be having 10 times the acceleration in the equation was what? 0.2. So have 0.2 equals to, now what is the force applied? 10. Force applied was what? Was 10 Newton. Remember they told us a force 10 Newton drag a mass along a horizontal plane. So that is it. Now minus mu k, that's what we are looking for, times what? Times the mass, which is what? 10 times what? 10, which is the what? The acceleration due to gravity. So we continue. 10 times 0.2 will give us what? 2 equals to 10 minus 100 what? Mu k. Mu k, that is the coefficient of what? The coefficient of friction. All together. So now let's continue. Now if we try to correct like things, we are going to be having 2 minus 10 equals to minus 100 mu k. So 2 minus 10 will give us minus 8 equals to minus 100 mu k. So divide both sides by minus 100, divide both sides by minus 100. This idiot cancel to give us just mu k. Then if we should continue from there, so minus will cancel out minus. So I just left with 8 divided by what? 10. 8 divided by 100 will give us what? 0.08. So that gives us the answer to this word, this question. So that is option what? Option B. Now, before we bring this video to an end, there's one thing you need to know about coefficient of friction. Now, coefficient of friction is the factor that determines the nature or the magnitude of friction that exists between two surfaces. It depends on the nature of the surfaces in what? In contact, whether they are rough, they are smooth, and so on and so forth. Now, another thing you need to know is that the value of coefficient of friction ranges from 0 to what? To 1. Are we together? So anytime you are calculating for coefficient of friction, be it static coefficient of static friction or coefficient of kinetic friction, if you have a value greater than 1, it means you are already wrong. If you have negative value, you means you are what? You are already wrong. So the value of your coefficient of friction, whether static or kinetic, is between 0 to what? To 1. So in this question now, our coefficient of friction is just 0.08. So it means that it is greater than 0, but what? Lesser than 1. So for that reason, we are correct. So in this question, the value of magnitude of the coefficient of kinetic friction is 0.08. Thank you.